Hey, welcome back to Mr. P. Helps with Precal. This is Unit 3, Topic number 4, Lesson number 1, which is on law of signs. And we're also going to be talking about the ambiguous case that could occur. So we're going to start off with a quick review of what you should have already learned in geometry. You know that the three angles of a triangle always add up to 180. No matter if it's a right triangle or not. So that means that you take 180 and you subtract the other two angles combined, which is 32 plus 90. So that's really 180 minus, that adds up to 122. Subtract that and you end up getting 58 degrees. Now, if it's a right triangle, you could use your trig functions or you could use Pythagorean theorem. Please do keep in mind that these numbers are just made up, so therefore they do not actually make a right triangle. So if you're going to solve it multiple different ways, you're going to get different answers. So if you use Pythagorean theorem, that means that you're going to get 16 squared minus the 12 squared, the square root of that. And that ends up getting you, let's see, 16 squared is 256 minus the 144 gives you square root of 112. Or you could use your trig functions, but like I said, you're going to get different answers because this is technically not a right triangle based upon its side lengths. All right, so law of sines. So basically just states that sine of this angle B is over this B divided by is the same thing as sine of A over A, which is the same thing as sine over C over C. As you can clearly see, this has already been done. This is actually something you probably have already done in geometry as well. So we can say that sine of 79 degrees over W is equal to sine of 52 degrees over 28. And then once you've done this, you cross multiply like this, which you can see the work done right here. And then you're trying to solve for W, so you divide both sides by sine of 52, and then you just put this in the calculator and you get your answer. And now you know what this is. Now, you're probably wondering, why not just use a trig function? Well, remember, this is not a right triangle, so you can't just use sine, cosine, and tangent. You can only do that when it's a right triangle. So this is what you do. This is what your method is for when it's not a right triangle. All right, so you're only going to use law of sines, or it's preferred to use, in these two scenarios. When you have angle, angle, side, which is the case in this question. So if you have angle, angle, side, and it's not a right triangle, then this is the preferred method. If it's not, we'll talk about law of cosines in the next video, or angle, side, angle. Now, this may or may not work for side, side, angle, which we'll talk about in the next slide as well. Because if you remember back in geometry, side, side angle can have more than one answer, or it might actually have no answers. It kind of just depends on the triangle. So in this case, I could do sine of 38 over A, which is sine of angle 8 over A, equals sine of 59 over 350. And then I would just cross multiply, and then I would solve. So this ends up being A times sine of 59 equals sine of 38 times 350. Divide both sides by sine of 59, put that in a calculator, and you've got your side length of A. All right, so a couple of questions here. I don't have time to be spending on doing everything, but I will do at least one of them. So let's say they're giving you this information. They're telling you that, keep in mind that capital letters are always angles. So this is one angle, this is another angle, and this is a side. So, well, first of all, I know that the third side is always added up to 180. So if I add these two up, I get 170. So angle B is equal to 180 minus 70. So angle B must be equal to 110 degrees. Okay, we'll talk more about that later, but technically it could also be, yeah, so it has to be 110 degrees in this case because it has to add up to 180, I'm sorry. So then the next thing I'm going to do is try to find sides A and B, so which I'm going to solve separately. So sine of 40 over A is equal to sine of 110 over B. Cross multiply, and then, I'm sorry, I know what B is. Why did I put that? So B is 10. So erase that, put 10 right there. Cross multiply, so that A is going to be equal to 10 times sine of 40 over sine of 110. Now it's just a matter of putting that into the calculator. So 10 times sine of 40. I press enter, and then I'm going to divide that by sine of 110. And that gives me about 6.84. All right, and then I'm going to go through the exact same steps, and I'm going to do it for B. So I would say, I can use the same one again. So I can say sine of 110 over 10 equals sine of 30 over b. And then do the same steps. So that's going to be 10 times sine of 30. And then divide that by sine of 110. And that gives me about 5.32 is my answer. If I pull over my predetermined answers and... gotten something to do. Okay, and like I said, for the sake of saving time, I'm going to move on. I do want to get to the questions at the very end. So it says, there is no other time, there is one other time that I talked about before where you don't want to use laws of sines, and that happens to be in the time when it's side-side angle, or ASS. Side-side angle, so if you know this angle, and you know this length side, and you know this length side. So this length side might be too short in order to hit back, because you know this angle, and you know this side, and you know this side. If this side is too short to hit here, that's going to have no solutions. You can't make a triangle. But if it's just perfect enough to hit this side, then it's going to create a 90-degree angle, and it's only going to have one solution. But what if this side is a little bit further than needed? Well, then you would have to move it like this. It would have to be over this way, because remember, you can make this length as much as you want. But then it would also have two answers, because if you made it shorter, it can also make this obtuse triangle. So it can make an acute triangle or an obtuse triangle, which means that there's going to be two possible answers if this side is longer than needed to go straight down. So that's the reason why you can have 0 solution, 1 solution, or 2 solutions, which, once again, that is something you covered back in proofs in geometry. You proved that angle side side is not a way of proving congruency unless it's a 90-degree angle. Then it becomes hypotenuse leg. All right, so in this ambiguous case, so I'm going to set it up just like I did before. So that's sine of this angle over 362 equals sine of 63 over 15. I solved, and then when I get sine of A, I would have to use inverse sine, which is second sine on your calculator. And what you're going to notice is that when you put inverse sine of this, it's not going to give you an answer. It's going to give you an error. And the reason why is because the top, if you do the top alone, 362 times sine of 63, and that gives you 322 roughly. Divide that by 15 gives you about 21.5. Now, the problem here is sine can never be more than 1. So therefore, there is no inverse sine of anything greater than 1 because sine never goes to that height. So that's not possible. So this doesn't have any solutions, which means that this side over here just isn't long enough in order to reach back to the side length. So you knew this angle, and you know this side's way too long. So I know that this side length, so this is that case where this side's really long. I know this angle, this side's really long, and this 15 centimeter side is just not long enough to reach back to this side. Now, it depends on a lot of things. Now, this is a big angle, and this is a very, very big side, so that really, really makes sense. But what if this angle had been 1 degree? If this angle had just been 1 degree, it would have gone straight across like this, and just because this side is much longer than this side, it wouldn't be ambiguous, because maybe that would reach because it's only a 1 degree angle. So it really kind of depends both on this angle, and it also depends on this side. So this side doesn't have to be as long as this side. It might be shorter and still have solutions, but that would mean that this would have to be less than a 45-degree angle. So it just depends on these two things will determine whether or not this side's long enough to either hit once or hit twice or not hit at all. All right, so this is... All right, different question. So this time we have sine of 42 over 29 equals sine of A. So it looks like we're trying to find A in this case is over 36. And you can see it's already been cross multiplied. We're trying to find sine of A. And you end up getting... This ends up getting you 56.17. Now, this is a completely different problem. So this last question had no solutions because simply this side just wasn't long enough in order to complete the triangle. But in this case, this one is so this is the angle that's at the on the base. This is the 36-degree angle. This 29 is long enough in order to reach this side again, but it's more than needed in order to make a 90-degree angle, which means that it's going to have this is one of those cases where it could be like this. If you know this side and you know this is 36, and this is 29, sure, it might be like that. Or that ambiguous case where it might actually, instead of this 90-degree angle, it can come back and hit over here, which is going to make a completely different angle right here. Now, what is that other angle? Because it can be in quadrant 1 or quadrant 2. So a 56.17-degree angle, as we learned in the quadrants, is the same answer. Sine of this is also equal to sine of its supplement, which would be 56.17. So 180 minus 56.17 gives us 123.83. So angle A could also be 123.83 degrees. It's possible because 123.83 plus the 42 is still less than 180. Now, if this is the case, if you do that and that plus this is more than 180, then that would not be a possible solution. And obviously, the these two angles can't be more than 180, so you would throw that possibility out. So this has got two possible triangles. So this angle right here can be either 123 or it could be 56.17, because remember, sine of this and sine of this are both exactly the same answer, because they both have the same size reference angle, and sine is both positive in the first and the second quadrants. Okay, so this is basically everything I just mentioned. As you can see, it's got the exact same work. And then you can solve for those two different sides. So basically, I found the two angles. So we got 56.17. Oh, different. Is it a different question? Let's see. 42, 36, and 29. No, same. Okay, I was looking at the wrong place. So we have here the two answers that we just came up with, which means that these are the two possible angles for angle B. So we come up with the two possible answers for angle A, and depending on angle A's measurement will determine what angle B's measurement is. So these are two possible angles for angle B. And then using that measurement of angle B, I've now solved for side B, which is on the other side. And since there's two possible angles, then there's two possible answers, and those are the two possible solutions for side B. All right, which is what's going to happen on question number 4, I believe. So I think with my 2 to 3 minutes that I have left, no, I only have time for this one, I think. So the first thing I'm going to need to do is I'm going to need to find angle C, because I have all the information I need for sine of 82 over 17 equals sine of C over 15. So cross multiply, and that's going to give me 17 times sine of C equals 15 times sine of 82. Divide both sides by 17, so that gives me sine of C equals this over 17, and then I would have to do inverse sine of that. So I'm going to do that first. So 15 times sine of 82, and then divide that answer by 17, do inverse sine of that previous answer, and I get, and this is what I've been doing in the calculator so you can see, so I got 60.89 degrees. C equals 60.89 degrees, because the sine of C gave me 0.8737, but then I had to do inverse sine of that. Okay, so now I have, this is C degrees. Okay, so now I have those two angles, so I can do 180 minus 60.89 minus the 82, and that gives me 37 point. So 180 minus 60.89 minus 82 gives me 37.11, and that's measurement of angle A. So angle A equals this. And then the last thing I would need to do is find side A, and then I would do that, and yes, I'm running low on time, so I would do the exact same thing I just did. So sine of 82 over 17 equals sine of 37.11 over side A. And then I would solve for side A, and then I would have all three sides. All right, thanks again for watching, and please look forward to law of cosines in the next video. Have a great day.